Hello students, I am here with another video from the chapter Light, a Reflection and Refraction. Before starting today's video, I would like to tell you all that till now what all things we have discussed in this chapter. So in this chapter we have discussed about the first part, that is reflection. And in reflection we have discussed a number of topics like I have told you about the concept of reflection, then we have seen the laws of reflection, then we saw about the characteristics of the image formed in a plane mirror, then we moved on to the curved surface, means curved reflecting surface, where we studied about the two mirrors, that is concave and the convex mirrors. Now when after seeing the things about these convex and the concave mirror, we saw the laws of reflection and the rules for obtaining the mirror images on different types of curved spherical surfaces. And before that I also told the terms which are related with these ray diagrams. And once we saw that there are different positions of the object where we are keeping these object in front of the concave and the convex mirror. We saw that the image is obtained at various positions. Okay, then after lastly we discussed about the mirror formula and the magnification about the reflection, means we have discussed about the magnification and the mirror formula which was related with the sign convention. So this sign convention also told us that it is also it is also helpful in determining the position and the characteristics, the nature and the relationship between the object and the image distance. Okay, next we have seen about the refraction, where we saw that till now I have told you about the different situation, means different ways by which we can see the refraction is going on in the various medium where the light is traveling from one medium to another medium. Okay, then we saw about the different ways by which we could, different mediums are there where we could see the refractions. Like there are two types of medium, mainly the rarer medium and the denser medium. And for that there is one diagram at the back of this this slide where it is there, the diagram. So this diagram is showing you about the refraction of light when it is taking place in the medium. Now I told about the rarer and the denser medium, so here also in the diagram I can show you that what about the rarer medium and the denser medium is about. So this rarer medium means that it is a medium where the molecules, the density of the molecule is less, and the light where it is traveling is the speed of light is more. Okay, the speed of light is more. And the medium where the speed of light is less, somewhere the speed of light is less. Okay, so the medium where the speed of light is more is known as the rarer medium, and the speed of light where it is less is known as the denser medium. So in this case I can means there are two mediums itself. So the first medium which you could see here is the air, and the second medium is here is the water. Okay, so this air and water is shown with the help, means they could be with the the air, which is the light which is traveling from one medium to another medium. It is but obvious that it is going to be bent. So once it is bending, then we can see that these ray of light is bending just because of the passing from one medium to another medium, and that is the property of the refraction. Means refraction says that it is the bending of light when it moves from one medium to another medium. As there are two mediums we talked about just now, that there are rarer medium and the denser medium. Now what about reflected ray and the incident ray? So all these things we are going to discuss now, and then we will see about the refraction which is taking place in the plain glass slab. Okay, so we move on to the first slide of this video, of today's video, that is going to show you about the refractive index. Yes, in the last class also we discussed about the refractive index, some concept of this refractive index we have seen. Why we have seen this refractive index and why it is so important? Because whenever the bending of light is taking place, it is in the rarer and the denser medium. So this rarer the denser medium, whenever it is taking place, it's because of the refractive index of any of this medium where this refraction is going on. So what was this refractive index? It was just the ratio where we compared the speed of light in air with respect to the speed of light in any medium. Means we calculated about the speed in various mediums. Now we go on to the other explanation about these refractive index with the help of this example. So this example says that the refractive index of the glass, that is about refractive index of the glass is being shown by the letter this n and small g. So this n means it is the way by which, it is the letter by which you could express the refractive index, that is 1.52 and it is a ratio, so it is not having any kind of unit. And that of water is that NW is about 1.33. okay, since the refractive index of the glass is higher than that of the water, then the speed of light in the water is faster than the speed of light in the glass. Now why this is happening? This is happening because the speed of light is going to be varying in the various mediums as the refractive index of these two mediums are changed. As you could see here, that refractive index of glass is more than that of the water, means glass is much more denser than the water. And we could also see on the basis of the molecules also, the density of these two are very different, because the density of this glass is much more than that of the water. Okay, so the speed of light is going to be faster through the glass through this means it is going to be faster in water as compared to the speed of light in the glass. Okay, now we can see that the refractive index of the medium is greater than that of the next medium. Why this is happening, we'll just explain about these things. So we can see that one medium is optically denser and the other medium is optically rarer. So we talked about the optical denser medium and rarer medium now very much. Okay, now we can see that if the value is more than 0, the refractive index is always in positive. Okay, and negative refractive index means that a material will have a negative refractive index when it has a negative permittivity or permeability. Okay, next is that the refractive index also provides a measure of the relative speeds of light in different media. Now we know that the refractive indices of the different medium helps the student to identify the direction in which the light would be bent while passing from one medium to another medium. As we know that whenever the light is refracting, it is because of the presence of this refractive index. Okay, now why this is happening, I'll just discuss it. Fine. So here this refraction, it is saying that light only refracts at the boundary of entry and where it is leaving, means it is going to refract here at the boundary and at the place from where it is leaving. Okay, when it is ending. So this is what is about the refraction, where it is taking place. It is taking place at the intersection of the point where the two mediums are getting interacted. Okay, now next thing is that how this refractive index vary with the wavelength. Now what is this wavelength? It is the wavelength of each and every light is different. Okay, now when we see that according to the definition of refractive index, the speed of light is the product of frequency and wavelength. Okay, now in 1 second how many times the wave is coming, means this light is moving from that particular place, that is its frequency, and till where it is moving, it is its wavelength. Okay, now what is that? Is the frequency of light will remain unchanged irrespective of the medium, whereas the wavelength of the light is going to change because it is based upon the refraction. Okay, so that is why refractive index also varies the wavelength. So wavelength has a relationship with the refractive index. Okay, so next is about how this light gets refracted. So whenever the light is moving from one medium to another medium, it is going to hit the molecules of one medium and it slows down. Okay, so please remember this, because it is hitting the molecules, it is losing its energy. So what happens, the medium the speed of light is decreased. Okay, because it is moving from one medium to another medium and it is going to strike the molecules of the medium. Okay, now next thing is that what is absolute refractive index. So we talked about the refractive index in the last class very nicely, and I think in details we have talked about. Now this refractive index was just the comparison of the speed of light in the vacuum with the speed of light in the medium. Means if there are two mediums, then we calculated that n is equal to c by v. So this n is equal to c by v, where this c was the speed of light in vacuum with respect to the speed of light in the medium. Now this ratio, that is n is equal to c by v, that is the refractive index of one medium with respect to another medium, is called relative refractive index. That is the n if the speed of light in, suppose that it is not in the vacuum, if it is air, and this is the next medium is the water. So this was the relative refractive index. But we need to know about the absolute refractive index. So what is this absolute refractive index? Absolute refractive index is just the comparison of the values of the speed of light in the vacuum, means with respect to vacuum, from the medium. So if one thing, we need two mediums to calculate this refractive index, we know that. So when we are calculating the refractive index, if one medium is the vacuum and the another medium is the means there another medium might be any medium like glass, air or water, it becomes the absolute refractive index. So this ratio of the refractive index, where the comparison is being done in the speed of light in the vacuum, the speed of light in the vacuum, that is known as the absolute refractive index. Okay, so this was about the absolute and the relative refractive index, and I think this is very clear now. So this absolute refractive index, how are you going to express? This is the speed of light, the speed of light in vacuum with respect to the speed of light in medium. Okay, this is known as the refractive index. Fine. Now if instead of writing this is known as absolute refractive index, and if instead of writing this vacuum, we write medium number 1 and this is medium number 2, so this is known as the relative refractive index. Okay, so this was all about the absolute and the relative refractive index. Okay, now we move on to the next part, that is the next fresh topic for today's discussion, that is the refraction through a rectangular glass slab. Okay, so we will go on to the to see that how is this refraction taking place through a rectangular glass slab. Okay, now before starting this, I will just tell you about certain means there are certain things which needed to be revised. I think you all know about all these topics, but still I am going to revise this so that it will be you can very easily connect the things in this refraction through rectangular glass slab. Okay, now before looking to this refraction through rectangular glass slab, we know that we need to know that light travels from a rarer to denser medium, and the light travels from denser to rarer medium, and we talked about this rarer medium and the denser medium very nicely. Okay, so this denser medium and the rarer medium, was what does it tells you? So rarer medium is again the medium where the speed of light was less, and this denser medium this speed of light was more, this was known as the rarer medium. Okay, and the speed of light is less in the denser medium. Fine. So this was about the rarer and the denser medium, which we just now discussed, that optically rarer medium means what and optically denser medium means what. Okay, so now there are certain other definitions also, like incident ray, refracted ray and the normal. As we have already discussed about the laws of refraction, and we firstly discussed in the last previous videos, we have also seen about the reflection, the laws of reflection, where we have been through these topics, that incident ray, refracted ray and the normal. So there was a reflected ray. Here we will study about the refracted ray, but the concept will remain the same. So what does this incident ray means? So this incident ray means with the ray of light which travels into the medium is known as incident ray. Okay, so the ray of light which is traveling from the medium, from one medium to another, which starts traveling. For example, this incident ray is the light which is traveling from the rarer medium to the denser medium. It starts traveling from this is known as the incident ray. Okay, so next, what is refracted ray? The refracted ray will be after passing from the another medium, this ray is going to be bent. Okay, either towards the normal or away from the normal, that is another thing, but this ray is going to be bent somewhere. Where it is going to be bent? At the joining of this surface, means at the surface where these two mediums are just interacting with each other. Okay, where one medium is ending and the second medium is starting. So at this bridge point, at this joining point, what happens? This refraction is taking place, and the ray which is refracted is known as the refracted ray, which shows bending is known as the refracted ray. So what does this definition say? So the refracted ray means it is a light ray which bends after refracting the surface. Okay, so this is known as refracted ray. So this was about the incident and the refracted ray. Now next thing is the normal, and again the concept of normal is very same. The ray which is perpendicular to the surface at the point of intersection is known as the normal. Okay, so what is this normal? So this is again a ray which we construct. So this is a ray which is going to be constructed. When the ray of light is incidented and refracted, we need to join it perpendicularly at the surface of this refraction where it is taking place. Okay, so we will draw this in a perpendicular to this glass slab or whatever it is, whether it is a water, it is or it's another medium. So whenever we are going to draw this normal, so normal will be perpendicular to the surface where this refraction, where this intersection of the refracted and the incident ray is taking place. Okay, so next, how does this refraction in the glass slab is taking place? Let us discuss now. So I hope that now this will be very clear to all of you that what is this incident ray. Incident ray is the incoming ray. And then what about the refracted ray? So the refracted ray is the ray which is bending and moving. Fine. So next is the normal. Normal means it is the perpendicular line which is drawn at the intersection of both the mediums. Next, the angles which are being drawn with the incident ray and the normal, as it was previously known as angle of incidence, here also it is going to be known with the same name, that is angle of incidence. And what about the angle of refraction? Angle of refraction will be similar to that of the angle of reflection in the last previous classes. Okay, so where we saw the angle of reflection there, now here just this name is going to be changed because we are reading the phenomenon of bending of light, that is refraction. So here the angle becomes angle of refraction. Okay, now the concept is same, that is the angle which is being drawn with the normal and the refracted ray. This is drawn in between these two, so it becomes angle of refraction. Fine. So this was all about the definitions which are related with this topic, that is the refraction of light through a glass slab. Okay, now next, now I'm just going over to this concept, that how is this refraction from in the glass slab is taking place. Okay, now the concept is clear about the incident ray, refracted ray and the normal. We can see that here in the glass slab, means suppose that this is a glass slab, so here the refraction is taking place 2 times. Now how is this light getting refracted 2 times? We'll see. So there is first part, let us discuss the case first, that is the refraction of light when it travels from a rarer medium to a denser medium. Why rarer to denser? Because this air is the rarer medium, and what is this denser medium we are considering? We are considering the glass slab as the denser medium. Okay, so this rarer medium means this light ray is refracted from this it is being incidented from the air, that is the rarer medium. Why? Because the speed of light is very less as compared to the speed of light which is more in the speed of light is more in this air. Okay, and then the glass is very less. Why? Because the molecules are more and the speed gets reduced when it is going to strike the object, when it is going to strike the surface of the glass. Okay, Okay, so the what happens here, the refraction is taking place two times, because once the light is going to enter from the air to this glass, okay, and it is going to bend once, and then again when it is moving out from the glass, it is again going to move when it is moving from glass to air. So there are two cases which we need to study. So this first one is the when the refraction of light is when it is traveling from rarer to denser medium. For example, this when the light rays travel from air to glass, that is from rarer to denser medium, it does not move in a straight line, it bends towards the normal. Now as it is going to strike obliquely, then the refraction is taking place because it is moving from rarer to denser medium, optically rarer medium to optically denser medium. That is why it is going to bend towards the normal. Why towards the normal? Because the speed of the light is getting decreased when it is moving from the rarer to the denser medium. Rarer means air to this glass slab. Okay, why? As just now I discussed that the speed of light is always getting reduced when it is moving from the from one medium to another medium, as we discussed in this diagram. Okay, now next thing is that case second will be, okay, now I think this first case first will be very clear to all of you, that when the ray of light is moving from air to glass, it is going to be bent towards the normal once. Why towards the normal? Because speed is getting reduced. Now next is the case 2 of this refraction, where this light is traveling from the denser medium towards the rarer medium. Now what is this denser medium? This denser medium is the glass and the rarer medium is this air. Okay, so this denser medium is glass and the rarer medium is air. Again this light ray is moving from the glass to outside this again into the air again. So again it is going to be refracted once more. So here the same example is being explained in second part, that is when the light travels from glass to air, means it is traveling from optically denser medium, that is glass, to the optically rarer medium, that is air. Okay, so again does not moves in the straight direction, it again bends. Why? It is again the two mediums are getting changed, that is why it is going to bend. Now where it is going to bend? It is since the speed was less in this glass, now as it is moving on into the rarer medium, the speed of light again it is going to be increased. Why it is going to be increased? Because the lesser collision of these particles are going to take place, because their molecules are away from each other in the air and it is very easy for the light to travel. Now what happens? Now I think these two cases are very clear to all of you, and now you have seen that how is this light getting incidented and then refracted once, then again twice, how it is again incidenting and refracting once again. So here what about the incident angle? Is the angle of incidence is the angle which is being made in between the incident ray and the normal, which is this. And what about the refracted angle, angle of refraction? This is between normal and the refracted ray, which is the R, which is represented by R. Okay, so this I and R concept is also very clear to all of you. Now again what happens in this second case? This incident ray, the light which is getting refracted becomes the incident ray for the second case. Why? Because this is moving from the one medium to another medium. So here this incident ray is getting changed. Okay, so this incident ray and the normal, between these two the angle of incidence is being formed, and again the refracted ray, this is which is bending away from the normal, is going to form the angle of refraction with the normal. So these two cases, I think it's very clear enough. Now next, after combining these two cases, what will happen? So the refraction through glass slab is going to tell you about. In this case, the light first travels from air to glass and then back from glass to air. So there are two refractions, please remember. So there are two refractions. Why? Because firstly the light ray is traveling from air to glass, and hence it is traveling from rarer to denser medium. So please make it sure that you know about the optically denser medium, the meaning of optically denser medium and optically rarer medium very clearly before studying this. Okay, now I'm repeatedly telling you that what is the meaning of this rarer and the denser medium, that is why. Fine. Now the first refracted ray bent towards the normal, and the second refracted ray is going to move away from the normal as it is traveling from glass slab to the air again. Okay, because I told you that the speed of light will be increased when it is moving from the denser medium to the rarer medium. Okay, next thing is that now when we are combining these two things, hence when it is traveling from the denser medium to a rarer medium, therefore the second ray becomes the emergent ray. Now one more new concept has raised about instead of writing the incident and the refracted ray, we are going to give the third name, that is the emergent ray. Now what is this emergent ray? I'll just tell you just in this, using this diagram which is drawn here, which is showing you the refraction. This is the combination of case first and case second. Okay, so what was case first? Where the light ray is going to travel from the rarer medium to the denser medium. Okay, denser medium. So here rarer medium is the air and the denser medium is the glass. So half of the concept is very clear. I just tell you about the emergent ray. What does this mean? So here again we'll see this red line which is being shown here is the incident ray, which is coming and striking on this surface of the glass. As it is a plain glass, as it is a surface which is having different density, it is going to bend towards the normal. Why? Because the speed of light is getting decreased. Again this refracted ray becomes incident ray for the second surface. This is going to again come out from the another part. Again it is going to bend. Why? Again it is going to be bended because this is bending because the density of the medium is changing. Okay, so this is becoming the rarer medium is going to be changed, so this denser medium is going to be changed into the rarer medium. So again this light ray is going to be moved away from this normal. Why? Because the speed is getting increased as the less hindrances are present in the air, because molecules are far away. Now the light ray which is coming out after the second side of this glass slab is known as the emergent ray. Now we are not telling it as a refracted ray, because this is once it is getting refracted. So this is the refracted ray in between, where the refraction is taking place continuously when the light ray is moving from one part of the glass slab to the another part of the glass slab. Once it is coming out, it is emerging out, it is coming out. That is why its name is the emergent ray. So this emergent ray is the ray which is coming out from this bit, is going to bend away from the normal once it is coming out from the second part of this glass slab into the air. Now this is about emergent ray. Now next thing which we will consider will be one more, again there will be one more concept. Now I just revise this. Angle of incidence is this I, which is drawn between incident ray and the normal. A refracted angle is this one, which is being drawn between the normal and the refracted ray. And what is this E? So again this is again one more angle is there. Again this is a refracted angle, and this one is angle E. This is known as emergent angle or angle of emergence, because this is being drawn between the emergent ray. This red one is the emergent ray and this normal. Okay, so this is the normal. So this normal and the emergent ray between, this is known as the angle of emergence. So please remember these small little concepts about the incident ray, the incident angle, refracted angle, what is emergent angle. So all these things should be very clear in your mind. Now one more thing, combining these two refraction of the above cases, where what are above cases? The first case where the light ray was moving from the rarer to the denser medium, and then second case was from moving from the denser medium to the rarer medium. Again it can be represented by this diagram which is drawn here in the side of this slide. Okay, now we move on to the next slide, which is telling us about some more concepts. That is, now when we extend this light ray, what happens to this? When we extend this original incidence ray or incident ray, which is brought towards the emergent ray. Now what we have to do, we need to do the construction in this glass slab. So when we are doing construction, it is being represented by a dotted line. Similarly, this normal will also be represented by a dotted line. Now here again this is being constructed, it is going to be extended. Which incident ray, if this glass slab would not be present here, what would have happened? So this incident ray might cross this glass slab without bending it. Suppose that it is crossing like that only. So what we need to do is the incident ray needed to be increased, means it is to be extended. So what happens? So this is going to be parallel to this emergent ray. Okay, so this is parallel to this emergent ray which is moving out. We observe that the original incident ray is emergent ray are parallel to each other. Okay, so these are these two rays, emergent ray and this constructed one is known as, this is going to be parallel to each other. Okay, so next what happens? So this angle which is being made with the emergent ray and the normal is known as angle of emergence. This I just now told you that what is angle E. Angle E is the angle of emergence which is being made with the emergent ray and the normal. Okay, and one more thing is there. Now what happens if this incident ray would cross like this without bending? So it would have be parallel line. So this line is having some gap in between. So this gap is known as, this perpendicular gap is known as the lateral displacement, because the ray has laterally sideways it has been displaced. Lateral means sideways the displacement has taken place. If this incident ray would have crossed the glass slab without bending, it would have been crossed in this manner. So the ray which is perpendicular, the perpendicular distance between the emergent ray and this original ray, direction of this original ray, okay, so these two rays is known as, between these two the distance is known as the lateral displacement. So please remember these words. Okay, now next we have seen in this diagram about various topics, like various new topics like this emergent ray, this lateral displacement, and what about the angle of emergence. So please remember all these concepts which is being present in this ray diagram which is related with the glass slab. Now because of the bending of this glass slab, because of the refraction of this glass slab only, the laws have, the two laws which we have studied already, has been arised, that whenever the refraction and this refraction is taking place because of the refractive index, that also we have already discussed. So now I'm not going to tell you about, again I'm not going to discuss the laws which is being followed here. So the laws remain same. That's the Snell's law, that is angle of incidence is the ratio of angle of incidence, sine of angle of I with sine of angle of R is always a constant, and that is known as refractive index. And that refractive index was again a ratio of speed of light of one medium with respect to the speed of light in the another medium. So children, in today's video I discussed about the refraction of the light in the rectangular glass slab, and where we saw that whenever the light rays are moving from the different mediums, so it is going to be displaced and it is going to be refracted. It is going to show you the bending. When it is moving from the glass slab, it is going to show 2 times the refraction will be shown. Okay, and that because of which angle of emergence, the emergent ray, and the lateral displacement also we discussed in details. So children, that's all for today's video. I will meet you all in the next video with the next topics to be discussed.